going to continue today with solving by factoring. So we're still looking at that same concept. We're just going to add in some more parts to it. Okay, so we're still solving by factoring today. All right, but the problems we're going to look at today are just a little bit more complex. Right, so remember we said yesterday the whole entire reason that solving by factoring works is all based on the concept that we need it to equal 0. So that is still our first goal today. Anytime that we are deciding to solve by factoring, we have to equal 0. Otherwise, the whole concept behind it falls apart. However, every problem that we look at doesn't equal 0. So we need to talk about then, okay, well, what do we do when it doesn't equal 0? So let's say, for example, we have d squared plus 3d equals 28. This is a 28, guys. Sorry, 28. Okay, so when we look at this, first thing we should hopefully notice is that this does not equal 0. Well, that doesn't mean we just throw in the towel and say we can't do it. We know from literal equations way back when in first trimester, we can always rearrange by just using our inverse operations. So if I want this to be a 0 over here, I'm going to have to get rid of that 28. And to move a positive 28, I'm going to have to subtract a 28. And whatever we do to one side, we absolutely have to do to the other. That's what keeps it an equivalent equation. Okay, so 28 minus 28 equals 0. Now, the key here is to make sure when you're writing these down, you're writing them down in the trinomial order. So we want it to be that ax squared, in this case it's d squared, plus bx, okay, again, in this case it's bd, plus c equals 0. If we get outside of our standard form, right, largest to smallest exponent, if we get outside of that form, then it's not going to match the things we're used to seeing when we factor. Now, once we get it set equal to 0, well, then it's not such a big deal because now everything looks exactly like it did yesterday. So if we take 1 times negative 28, we'll get negative 28, and we will start listing. 1 and 28. 2 and 14. So hopefully the more you've done this, the better you've got at it. The quicker you are at factoring, the less work this is going to take. Okay, we know because it's a negative 28, we need one positive and one negative. We want the larger number to be positive, so the smaller one to be negative. So the set we are going to pick here is a negative 4 and a positive 7. So that tells us that this is going to factor into a d minus 4 and a d plus 7. Right? It equals 0. We're just replacing the trinomial with its factors. And then we can set both of those equal to 0. So I can say d minus 4 equals 0 and d plus 7 equals 0. And I'll solve these both individually, just like we did yesterday. So d equals 4, and d equals negative 7. Now, I'm not going to lie to you. That's still kind of a lot to think through. These problems can get kind of lengthy, which means it's that much more important that we understand the previous skills. Because while they might take us time to do, it shouldn't be adding a whole lot of new information. If you feel like you're struggling with that information, those past concepts, you probably don't know well enough, and that might mean you need to set up a time to meet with me and work during my office hours, core time, something. All right, so let's look at another one. Let's say we have x squared plus 8 equals x plus 28. Now, this one definitely looks way more bizarre than ones we've seen in the past. But again, that's okay. We still know how to manipulate equations to make them equal 0. So we kind of have two choices here, right? We have 2 over here and 2 over here. We could kind of move either way. My suggestion is that you always move if it's an option so that your x squared stays positive. Okay, if x squared becomes negative, then there's a negative 1 in front instead of a positive 1 in front, and we can no longer factor with that trinomial shortcut. Okay, and that's a lot of extra work just because of which way we moved numbers. So if we want this x squared to stay positive, we want to move all this other stuff over here to the left. So if I want to move a positive 28, I'm going to subtract 28. So that gives me an x squared. These are like terms, so I can put them together, right? 8 minus 28 gives me a negative 20. Those cancel. Now I'm left with an x. That does not equal 0 yet. So I need to do some more work to get this to equal 0. So to move a positive 1x, I'm going to subtract it. And again, just like I said above, we want to get this in that ax squared plus bx plus c order, which means I want this x to go in the middle. Okay, I want x squared minus x minus 20. Mathematically speaking, you won't be wrong if you write down x squared minus 20 minus x, but that's not in our trinomial form to factor. Okay, so we need this format to be able to factor. So our x minus x becomes 0. And now we're just factoring. So 1 times negative 20. We're making our list again. Hopefully at this point you feel like you can do this quicker. We know we need one of each, our larger to be negative. And so we want 4 and negative 5. Now, right, the reason we want 4 and negative 5 is because when we don't see a number in front here, that's really a 1. And 4 and a negative 5 give us a negative 1. So this is an x plus 4 and an x minus 5. And all of that work just only got us factored. Now we still need to do the solving. So we have an x plus 4 equals 0 and an x minus 5 equals 0. Over here. Okay, so when we solve those, we know that x is negative 4 or 5. Okay, so one last one we're going to look at. And I don't know if you've noticed, but I kind of have ignored any factoring that is that difficult to factor, which means this one's going to be a little bit more work. So let's say we have 3x squared plus 7x plus 13 equals 9. Okay. This does not equal 0, right? That's always what we check first. Does this equal 0? No. So we need to make it equal 0. So we need to get rid of our 9. This is a like term with the 13, so I can subtract that with the 13. So now we'll have 3x squared plus 7x plus 4 equals 0. Okay, so it's a trinomial, so 3 times 4 gives us 12. 1 and 12, 2 and 6, 3 and 4. Everything is positive. We want the set that will add up to 7. Now, when A is not 1, we cannot factor this as the shortcut, which means we've got to go the long route here. So we're going to split this 7x into a positive 3x and a positive 4x. Bring down the 4, bring down the 3x squared. I'm just ignoring the 0 for the time being because I got to get this whole thing factored. So I might as well not worry about it while I'm factoring. Okay, so we're going to split this in half and factor by grouping. So my GCF on the left is 3x. When I pull that out, that leaves me with an x plus 1. My GCF on the right is 4. And then I can go into my two binomials of a 3x plus 4 and an x plus 1. If you're not sure where those numbers are coming from, you need to go back and look at factoring. Okay, and now that we're here and we have it factored, right now we can go back up and say, okay, well, let's let this equal 0. So that means either 3x plus 4 equals 0 or x plus 1 equals 0, right? I told you these aren't always short. And we will finish solving with an equation. Here. So we'll get x equals -4/3 and x equals -1.